Hey everyone, welcome back to the channel. Today, we re-diving into a topic that's both fascinating and a little bit chilling. Comet C2023-A3, also known as Sukunshin ATLAS. This celestial visitor is set to grace our skies in late 2024, and it's predicted to be one of the brightest comets in decades, maybe even visible to the naked eye. It's an exciting time for stargazers. Now, let's be crystal clear right from the start. Comet Atlas is on a safe trajectory. It will pass by Earth at a comfortable distance of about 71 million kilometers, or 44 million miles. There is absolutely no risk of it hitting us. Planetary scientists have its orbit plotted with incredible precision. So, you can sleep soundly tonight. But what if? That's the question that sparks our imagination, isn't it? What if something completely unexpected happened? Some cosmic fluke that knocked Comet Atlas off its path and sent it hurtling toward Earth. This is purely a thought experiment, a journey into the realm of science fiction based on scientific principles. So, grab your imaginary space helmets and let's explore this what-if scenario together. First, how could a comet even change its path? It's not like it has a steering wheel. The most likely, though still incredibly rare, culprit would be a gravitational nudge. Imagine the comet flying past a massive, uncharted object in the outer solar system, a so-called rogue planet or a large asteroid we haven't discovered yet. The immense gravity of this object could act like a slingshot, altering the comet's course. Another, less dramatic possibility is outgassing. As the comet gets closer to the sun, its ice vaporizes, shooting out jets of gas. If these jets are uneven, they can act like tiny, unpredictable rocket thrusters, slightly changing its path. But to divert it enough to target Earth, that would require a massive, perfectly timed series of events. The odds are astronomical. Let's say the impossible happens. The alarms at NASA, ESA, and other space agencies around the world would start screaming. Their planetary defense systems, like the Near-Earth Object Wide Field Infrared Survey Explorer, or NEOISE, are constantly scanning the skies. They would detect the change in trajectory almost immediately. The first phase would be frantic, non-stop observation. Every telescope on and off the planet would be pointed at ATLAS, gathering data to confirm the trajectory, calculate the impact point, and estimate the time of arrival. This isn't Hollywood. There wouldn't be instant panic on the streets. The information would be carefully verified and shared between international scientific bodies before any public announcement. The world's leaders would be briefed in emergency sessions. The key question would be, how much time do we have? If we had years or even decades of warning, humanity would have a fighting chance. This is where science, not science fiction, gets really exciting. Our primary strategy would be deflection. We wouldn't try to blow it up, as that could create a deadly shotgun blast of smaller, equally dangerous fragments. The goal is to give it a gentle push, to alter its course just enough so it misses Earth entirely. One leading concept is the kinetic impactor, which is exactly what NASA's DART mission tested successfully in 2022. We would send a high-speed spacecraft to collide with the comet. It's not about brute force, but about transferring momentum. A small nudge, applied years in advance, can result in a miss of thousands of kilometers by the time it reaches Earth's orbit. If we had multiple spacecraft, we could perform a series of coordinated impacts. Another option on the table is a gravity tractor. This involves parking a massive robotic spacecraft near the comet and simply letting its tiny gravitational pull slowly tug the comet onto a new, safer path over several years. It's a slow and steady approach, but it's also very precise. In a more extreme scenario, we might consider using a standoff nuclear detonation by exploding a nuclear device at a distance from the comet. The resulting radiation would vaporize part of its surface, creating a powerful jet that pushes the comet away. This is a high-risk, high-reward strategy, as it could risk fracturing the comet, but it would be a powerful tool in our arsenal if time was short. But what if we only had a few months? This is where the scenario gets much darker. Deflection missions take years to plan and execute. With only months to go, our options would be severely limited. The focus would shift from prevention to mitigation. Scientists would work around the clock to pinpoint the exact impact location. Would it hit land or ocean? The difference is critical. An ocean impact, especially from a large comet, could trigger mega tsunamis that would devastate coastal regions worldwide. A land impact could create a crater miles wide, vaporizing everything at ground zero and throwing enough dust and debris into the atmosphere to cause an impact winter. This would be a global catastrophe. The dust cloud would block out sunlight, causing temperatures to plummet and crops to fail on a global scale. It would be a mass extinction event. Faced with this certainty, the world's governments would have an impossible task. How do you prepare? The priority would be the continuity of human civilization. We'd see a massive, coordinated effort to evacuate the predicted impact zone and surrounding areas. But where would everyone go? Resources would be stretched to their absolute limit. We'd see the largest humanitarian effort in history, focused on building hardened shelters and stockpiling food, water, and medical supplies. The psychological impact on humanity would be immense. Knowing the exact date of a potential apocalypse would test the very fabric of our society. We'd likely see incredible acts of unity and heroism as people come together to face a common threat. But we'd also face chaos and despair. The challenge for leaders would be to maintain order and hope in the face of oblivion. The focus would be on survival, ensuring that some part of humanity, along with our knowledge, culture, and the seeds of life, could endure the aftermath and one day rebuild. Let's bring it back to reality. The scenario we just walked through is a sobering reminder of our place in the cosmos. We live in a dynamic, sometimes dangerous, cosmic neighborhood. But it's also a testament to human ingenuity. The fact that we can even have this conversation, that we can track comets, understand their physics, and devise real-world plans to protect ourselves is incredible. Programs like NASA's Planetary Defense Coordination Office are our silent guardians, working every day to ensure that a scenario like this remains firmly in the realm of fiction. Comet Tsukunshin ATLAS is not a threat, it is a gift. It's a chance for us to look up at the night sky and feel a sense of wonder, to connect with the vast universe we are a part of. So, when late 2024 rolls around, I encourage you to go outside, look up, and enjoy the show. It's a beautiful reminder that the universe is full of marvels, and we are fortunate enough to be here to witness them. Thanks for joining me on this deep dive today. It's a big topic, and it really makes you think. If you enjoyed this thought experiment, Make sure to hit that like button and subscribe for more content that explores the wonders and what-ifs of our universe. Let me know in the comments what you think humanity's first move should be in a situation like this. Stay curious, and I'll see you in the next video.